Hi, my name is Abigail Peelan, and today we'll be solving a connected objects problem. Our problem is a sled dog is dragging his sleds A and B in the snow. The coefficient of friction is going to be 0.08, and that is kinetic friction because we're sliding. Our question is if the tension in rope 1 is 140 newtons, what is the tension in rope 2? We have a few knowns, so we know mu of K is equal to 0.08. We know that tension 1 is going to be 140 newtons. And we are trying to find tension 2. We can also assume that the ropes are massless. That way the tension throughout the whole rope is going to be the same, allowing us to have the acceleration of the whole system to be equal for every single object. That makes it easy so that we can calculate the acceleration here and plug it into here in order to find our tension 2. So first we're going to draw the free body diagram for sled A. So we got our normal force, our force of gravity, we've got tension 1 right here, and we've got kinetic friction right here. We know our force of gravity and our normal force are going to be equal. Force of gravity is going to be 9.8, which is our acceleration due to gravity, times our mass of A. That's going to equal the normal force. Then we're going to plug in our values to find the acceleration using this equation. Our F net is going to be tension 1 minus the force of kinetic friction. That's going to equal our mass of A times our acceleration. Tension 1, 140. The kinetic friction, if we remember, that is our mu times our normal force. Normal force is 9.8, mass of A is 100. Our mu is 0.08, and that is going to equal our mass of A, which is 100, times our acceleration. Acceleration, when you solve this out, is 0.616 meters per second squared. Now we're going to make the free body diagram for sled B. So we've got our normal force, force of gravity, still equal. Tension 2 over here, and we've got our tension 1, and also from the same point, our kinetic friction. Now we're going to plug in, so we've got force of gravity is still equal to normal force. Force of gravity is m of b times 9.8 equals n. Now we're going to find our F net equation. So that's going to be T2, which is what we're trying to find, minus our T1 plus our force of kinetic friction. Because they're in the same direction, we can add them. That's going to equal our mass of B times the acceleration, which we know from up here. When we plug this all in, it's tension 2 minus tension 1, 140, plus our kinetic friction, 9.8, times mass of B times our 0.08 from the mu. That's going to equal 80 mass of B times the acceleration, which we got was 0.616. We have that, and our tension 2, when you solve this out, is going to equal 252 newtons. Now this answer makes sense because tension 2 has to be greater than tension 1. If you look at this free body diagram here, tension 1 is over here, and tension 2 has to be the sum of these two. So it cannot be less than our tension 1. It wouldn't make sense. Thank you.